So we'll do a round robin. We'll start here, and then we'll say hello to those folks on the phone again. Most of the same crowd, but anyway, we'll do that anyway. So this is Monica, the Heritage Program.
Amy Trammell, Heritage Program.
Justin Fulkerson.
Tina Boucher.
Great. And Angie, is that you and Nancy, or just you, Angie?
It's me and Nancy. We're both here now.
Great. Thanks for joining us. David, what are you joining us again? Yeah, my WebEx, but not on the phone yet. Erin, were you able to join in?
Yep, I'm here. Erin Juliana.
Great. I was just telling Tina that you were participating for Jen while she's out, and I was trying to remember if she was in Hawaii or some other fun place.
She's out for fun.
That's what I was thinking. Well, thanks. And Jen, you're on the WebEx as well.
Yep, I'm here. And John DeLapper,
I am here. Thank
you. Thanks for participating again. And Sue, you're on the phone as well?
Yes, ma'am.
All right. Thank you, everyone. I'm sure there'll be a few folks that join us throughout, but it's great to have you all participating. And I'm going to go ahead and pass the presentation to Tina. We have somebody just started blowing leaves outside of our conference room as soon as we started this one, so hopefully it seems like they're moving away, but hopefully it's not too loud. And here it's okay.
Yeah, hi, I'm Tina Boucher. I'll be presenting the TerrestrialCoarseFilterCE draft distribution models. And should we move the speaker closer to me?
You got that little
microphone.
microphone.
I'll do it on my phone.
Yeah. We're dragging a speaker, sorry. There, okay. Stop dragging it soon.
There you go.
Okay, thanks. If you can't hear me, let me know. So basically, I've already been over this in our methods presentation, but we wanted to select vegetation types that captured kind of the main functions of the area, also covered the majority of the REA area, and we wanted to also have them linked either by common vegetation or and also a similar disturbance regime and soil type if possible, but all this with kind of our what we have available for our mapping layers. So one of my earlier presentations, I showed the list of conservation elements and also the source map that we will be deriving them from. So for our classes that are above tree line, the tundra classes, we'll be using our Alaska vegetation mosaic is what I'm calling it, and a lot of people are familiar with this mosaic product that we've put together over the last few years. It's basically all the vegetation maps in Alaska, and it's mostly the majority of the area is the BLM maps produced by the DU maps produced by BLM, and then also for this, a lot of Park Service maps mosaicked in. And we had to kind of create a common crosswalk, so kind of a course classification where we had to dumb down some of the maps that were really finely detailed, like some of the Park Service maps. But the three classes that we're deriving from those maps are all part of the course classification. Those are the alpine dwarf shrub tundra, I'm calling it alpine and Arctic tussock tundra to indicate that it's similar to the tussock tundra that we described on the North Slope and the foothills of the North Slope. And then also the upland low shrub tundra. And then from the National Land Cover Database map, the NLCD, we're going to derive the forested classes. And that's the updated NLCD. It's a 2011 update, so there isn't any current or new Landsat imagery that was used for it. It was just updated with disturbance layers and some other information, kind of a long list of different sources of information on disturbance. So it's really actually not very different from the 2001 map if you look at the change pixels. And then to get to the floodplains, we have a lot of questions about riparian vegetation from this REA. So we're proposing using, well, we did use, and I'm going to show you what it looks like, the superficial deposit layer from the Alaska permafrost map. It's one of the attributes within that shapefile. And then from within that polygon, we're going to we've just extracted the forest and shrub classes. So I'll show you what that looks like. And each one of these maps kind of has its limitations. The vegetation mosaic, of course, is all different maps, so different accuracies. NLCD, they don't have a 2011 accuracy assessment, but the 2001 NLCD had I think they reported for our project area, which is the interior boreal. That's the bulk of the area from the NLCD was the interior boreal, and that was like a 64% accuracy. So each one kind of has some built-in inherent limitations. And then I'll show you some of the limitations of the floodplain line work too as we get to that. So just to show some pictures right off the bat, because land cover classes aren't that interesting. These are the classes we're going to be, that we're using the NLCD map to extract. We have the upland spruce hardwood forest, the music spruce, and then on the right, the lowland and wetland classes, floodplains and woody wetlands. Then these are the three classes that we're going to derive from the Alaska vegetation mosaic, all pretty recognizable tundra types. So I'm going to present the mosaic data a couple different ways, and I see something different in it every time I present it a different way. So this is partially for my own interest. The green are the NLCD classes all together, and then the pink is our Alaska vegetation mosaic. And one thing I just noticed when I looked at it this way was that the NLCD, where's my mouse? There's actually some burned areas, and I thought they were part of I knew there were some burned areas, but they're not mapped as burned areas. They're actually, when I looked into it this morning, they're actually shrub classes within the NLCD map, and that's one of the new class. It's a change from the 2001 NLCD, and I have to probably go back and capture those, because actually what they're mapped as now is NLCD shrub scrub, which is everything that's 20% shrub all the way up to a 5-meter tall tree. So it's a really broad class. So all of the early successional burn polygons that were within forested classes, I think a lot of them got changed to this shrub scrub class. So I want to go back and capture those. And here I wanted to show the overall distribution of classes and the basic kind of coverage that we have. So we have pretty good coverage. There aren't a lot of gaps, but those burned areas do kind of stick out. And I'm going to next just present them one by one, and then some of the classes are a little bit easier to comprehend when they're kind of juxtaposed with closely related classes. So I'll kind of look at them in pairs as we go. Go ahead, Monica.
Questions on the last map. I'm just curious. Looks like, so most of the kind of areas that look blank are burned.
Like this, where my mouse is, there, here.
But then
over
the buffer,
here.
there's kind of
I think this is just alpine. That's up in the mountains. Is that what you're?
Yeah, I just when I looked across,
Yeah.
oh, it's just one area, but that's.
Well, actually, yeah, I'll check on what, because if it's alpine, it should be in the Alaska range. Maybe it's, I'll look at what it is. I'll check that one, because maybe
Glacier.
It could be, it looks kind of right near the crest of the range, but every time I look at it, there's a new thing to check. And we just put these together like last week, so there's still some checking going on. So first I'll look at the spruce hardwood and then also the music spruce forest. So the spruce hardwood class includes both mixed and deciduous forest, and pretty much it's a spruce hardwood type that usually has a deciduous phase after disturbance such as fire. And this is its distribution according to NLCD without the floodplains taken out. And then I'll kind of juxtapose that with our upland music spruce forest. And this class, as mapped by NLCD, actually includes coniferous forest. It's either black or white spruce, but it doesn't include wetland forest. It's the music sites, upland sites. And one thing that kind of characterizes the upland white spruce forest in particular is that it often lacks a hardwood cirral stage after disturbance. And this is its distribution according to NLCD. And I think an interesting way to look at it is kind of juxtaposing the spruce hardwood with the upland music spruce forest, so you can kind of see some of that pattern where it seems like it's a little bit lower elevation where you have the spruce hardwood and the brighter green, and then the music spruce does tend to be a little bit more on the kind of the fringes of the forest distribution, and up here in north of Tok and that kind of uplands between the Tanana and Yukon. Next, I'll look at the lowland, the woody wetland, and the floodplain classes. And just to reiterate, these are the black spruce wetlands, and it also includes, this is the NLCD definition of this class, includes shrubby wetlands and also sedge shrub wetlands. So anything that has woody vegetation and is also a wetland. This is the NLCD distribution. And I'm going to juxtapose this with floodplains because they do seem to occur kind of close to the floodplains, but even without, they're generally not in any of the floodplains. That's actually a pretty good separation there. So our floodplain layer that we have access to, really we're kind of limited in the quality of the floodplain mapping. It only goes down to floodplains that are a mile wide. So there's a lot of floodplains that aren't mapped. But you know, we talked about this at a bunch of our different meetings, and there wasn't a strong movement to hand delineate floodplains, which is really a tremendous amount of work for somebody to do. Not impossible. We did it for the YKL, but we're not planning on doing that for this particular REA. But then there's also some reasons not to do it, because if once we delineate the floodplains and we have a floodplain layer that doesn't match with some of the other source data sets that we're relying on, like for example from some of the SNAP products. So you might create just another kind of a problem by hand delineating them. But I'll show you some of the limitations just with some screenshots. So this is a basic distribution of our floodplain forest and shrubs. Because again, this is the all of the forested classes and shrub classes within that floodplain polygon from the Alaska Permafrost map. And here it is juxtaposed with the lowland woody wetland. You can see a lot of those wetlands occur on the ancient terraces.
What is that boundary? On
Okay.
the southeast side, there seems to be an artificial threshold there.
Where? Oh, here.
Right there, yeah. Because these are both that. Well, it's more than LCD data set.
This is an LCD.
Yeah.
They have
You know the black stuff?
yeah,
Oh,
no, look at that. There's kind of a hard line there.
Sure, but it looks
Pretty chopped.
It's very chopped. I mean,
Yeah.
it just looks very chopped, but I don't know. Maybe it may not be. Because it looks pretty chopped on the Brook Range too, but that's real. So
Yeah, I remember, like, the LiDAR was really blocky in that section around Fort Yukon, so
yeah.
it could be part of that.
okay.
Yeah, I'll take a look at it. Not that there's anything we can do about it.
No,
but
that's
it's
just
just one of those. Yeah. Oh, so I just did, Marcus was explaining to me when he was doing these maps how he wasn't that comfortable with the floodplain, the accuracy of the mapping, but this is compared with a Google Earth backdrop, so it's not really a fair comparison. But then you can see the scale. I mean, sometimes these things are kind of like a mile or two off from the actual mapping. So what we have is a representation of floodplain distribution, but it's not really can't really be used to say this is where the floodplains are, except in the larger floodplains, like, you know, the Yukon is actually pretty good in most places. So just a few other screenshots. You know, the Kobuk is kind of up in the tundra, and we have the Koyukuk, and yeah, just then we played around with different, you know, it is an AD27, so we did some transformations, and that wasn't the problem. So it's just, you know, it's a different source data, and that's just what we're dealt with, basically, or the hand we're dealt with at different map layers we have access to. So I just wanted to mention there's a reason that we want to be consistent with the data layers that we use. And this is from, you know, Nancy presented the ThermoCoarse predisposition model yesterday, or it was yesterday, right? Mm-hmm. And that actually draws heavily on these same source data layers. It's the Alaska permafrost map layers are, I believe they're kind of, I think it's pretty similar. I'm going to compare it more closely in the coming days, but I think the floodplain layer and some of the ice content is all from that data set. So that's one reason. If we want to use the SNAP products to describe how things are going to change in the floodplain, we'd want to be consistent with our data sets. So moving right along to our classes above tree line, I'm shifting over now to the map, the land, the habitats will be derived from our vegetation mosaic. So the upland low shrub tundra, generally that occurs in these well-drained sites above tree line. And this is the distribution according to the Alaska vegetation mosaic map. And that one is, I don't have too much to say about that. It's pretty straightforward. The Arctic and Alpine tussock tundra generally occurs on above tree line also, and gently sloping terrain underlain by permafrost, cold acidic soils. And this is the tussock tundra distribution. I guess I think I mentioned in my earlier presentations why I didn't want to use NLCD for these classes, but I guess I should reiterate that. The classes are, they're not defined the same way. Like, for example, there is a tussock tundra class, but it requires 80% cover of sedge and less than 20% cover of shrubs, and that's a very uncommon, it doesn't really occur that way. So, and then the dwarf shrub has similar problems. Everything, it got way overmapped, and so we actually just felt that this was a better representation.
Do you have any areas where they were misclassified, or that where the NLCD overlaid with some of these classes from the mosaic map, where you had to decide which one to use, or is it where?
No, because we only use NLCD for forest, and so we did all the forest first. Floodplain and forest were first, so we considered the NLCD. We kind of made a priority of the forest. And so those kind of, in the priority list, that was the first order. And then the vegetation mosaic is kind of the second, third, fourth order. So we did like,
you kind of excluded those areas.
Well, we clipped the floodplain, then we took the forested classes and made our CE distributions. Then from what was left, the non-forest and, you know, alpine classes, we created those from the vegetation mosaic. So we didn't. There was never you never had to make that decision. And the last class, this is going rather quickly, is the alpine dwarf shrub tundra class. So generally well-drained sites, rocky residual soils, and the distribution according to the Alaska vegetation mosaic. You can see it matches quite well with the alpine areas. And I just wanted to juxtapose that one with the tussock tundra. You can kind of see the pattern there. The tussock occurring at lower elevation at a more gentle terrain. And those are the CE distributions.
Mm-hmm. About the floodplain. I know, I guess it makes sense that you want it to match up with the SNAP product, but then on the other hand, for YKL, one of our kind of major take-home messages was kind of the impact from human development on the floodplains, and that might be mapped a little bit. If we corrected it, it might fit better those interpretations from impact.
Right.
Like if we're kind of looking at mining or other kind of human-related disturbance, that we might be missing it a little bit if we don't clean up that way. I mean, I guess we kind of pick and choose, but.
I know. Well, we have the the stream data set, which also has some limitations, I guess, but
for YKL, we actually went through and
hand delineated.
Went
spent a lot of time at it.
Checked at least the polygons we were going to be using. That would be.
Well,
if you have a feeling if that would be, because it seems like the climate-related data would be kind of broader in scope, whereas the human dimension would require a little bit more precision. Just kind of thinking about.
Yeah, for the North Slope, the only data set that really matched with the some of the floodplain mapping was we had the ThermoCars predisposition model, and we'd also used the floodplain. The floodplain mapping is much better on the North Slope because there was that new subsections layer, and we don't have that kind of an update for. I mean, I guess the Alaska permafrost map, but that's still not as updated as the northern subsections mapping we used for the North Slope, which was really very, very satisfactory. Really like that data set. And this one, I think, is more of a work in progress. And so, I mean, I don't know. It's a kind of a.
Just thinking that if we saw a fair amount of impact for YKL, that this ecoregion would, this area would be even more impact from human development since YKL is so unpopulated.
I mean, Marcus and I were talking about this floodplain issue earlier, and we thought, well, maybe we haven't actually fully finalized our distribution models, especially with the floodplains. We haven't actually eliminated them from. We haven't actually separated them out yet. We just are we are showing distributions and limitations. Well, maybe we should keep all the forested types inside the floodplains, and then for certain management questions that deal just with the floodplains, maybe we would want to look at the floodplains separately using that clip with the permafrost from the permafrost map. So we're going to keep looking at it in different ways, and I think actually when we start intersecting the SNAP products and the permafrost, I think it might be at that point when we make our final decision as to what our CE boundaries really should look like and whether we should really use that floodplain boundary or not, or maybe we should just use it for certain intersections and not others. It's, a little bit of a...
Yeah, Angie and I here at SNAP are having little side conversations about the intersections between some of the data layers used in our material and models and these, and trying to, obviously we need more conversations about how we can try and get our data to play with yours. It's a struggle because, of course, El Fresco looks at slightly different vegetative categories, and then the ThermoCarst layer includes that kind of floodplain lowland component, but again, each model is fine-tuned differently because it has different objectives in mind. So we've been doing a lot of talking, prior to this meeting about those categories and how to get the best possible output from those. So we can continue that conversation perhaps with you as well.
Okay. Well, if you want to, if you have anything to say about floodplains right now, feel free to give your 2 cents.
Well, I mean, I think the picture that's on the screen right now makes it obvious how different the vegetation is and how crucial that is, but it's just trying to pin down, I mean, we were talking about looking back at the alfresco layers to see to what degree if any, floodplains are captured there.
I don't think they are. I mean, I looked at it.
Really, yeah.
I don't think they really are. So I don't think we'll have, alfresco won't be giving us information about how floodplain vegetation is changing.
No, I don't think so either, because
I looked at that earlier to see if there was any, to see what the agreement was there with that, the North American land cover, but sorry, the one that the alfresco vegetation.
Yeah, it is North American land cover. Yeah, I mean, the problem is that any really large water bodies, then you get pixels that pop out as unvegetated, and that obviously affects, fire behavior and succession and so on. But and in the really big, some unvegetated pixels get pulled out, but not these lush green, but also somewhat transient, because these are all, of course, braided rivers. So these are floodplains are moving landscape features to some degree. But yeah, I don't think we're capturing them well with alfresco, certainly.
No, I think with the permafrost, with the GIPL model, and then with the thermokarst predisposition model, it seems like that's where you'd have more agreement with the floodplain lines.
Yeah, that should be capturing. That should be capturing it very well, because that's honing in on how the DEMs capture low points in the landscape. So that should be capturing it. We're still figuring out some of the fine-tuning questions regarding the calibration of the permafrost, of the thermokarst disposition model. So we had a meeting talking about that yesterday, and we're going to try and meet with the modeler Helen to talk through some of the questions about how it's ground truth and calibrated mainly. But yeah, I think there'll at least be some interesting pieces coming out of that.
Yeah, because just looking at it on kind of a coarse scale, just kind of comparing that, it seems like the NLCD woody wetland and then the floodplain area, it seems like there's a lot of agreement in we'd be able to make some assumptions with some intersections there. So, Jamie?
Yeah, I mean, I think this is good discussion, but I'd like maybe to hear from some of the BLM folks, because it essentially gets down to the mismatch of scales that we are always struggling with these REAs. Because a 1 kilometer floodplain is certainly ecoregionally important, but it's not necessarily the scale at which management's happening. And so getting back to Monica's comment about, the YKO was really important to map those smaller floodplains, just because it's where most of the placer mines are going in. It seems like we're missing an awful big piece of the management picture if we don't include that.
The finer floodplains.
The finer floodplains, or the potential impacts to those finer floodplains, even though it's not operating on the same scale as the climate impacts. It's still a fairly significant part of the REA.
And we also, for YKL, it was really important winter habitat for moose and muskrat. So we use that data as one of our input layers for those species. We don't have the same ones here, but it's been considered.
This is Eric Geisler.
Hi, Eric.
I think it's important to keep those minor floodplains, and just as you're on your current slide, as you're showing there, the difference in vegetation is so distinct. I think it's important to identify that difference across the REA.
So to get that fine feedback. To get the fine scale floodplain, I think we'd have to use like the NHD streams and then buffer them with a pixel on either side or something like that.
We kind of did.
That would be
where we hand delineated certain polygons based on the StatGeo maps and imagery, and then also use the NHDs to buffer the really small streams. But at least that kind of cleaned up some of those larger floodplains.
Yeah, StatGeo actually is even more coarse than the permafrost map superficial deposits.
Yeah,
so,
but you could use as at least something to modify instead of hand delineating them all.
This is Tim. Well, my head's spinning a dozen different ways right now, but I'm really thinking that at the scale we're going to be using this RIA data, it's useful to know this is approximately the floodplain, but we're not going to rely on that to determine if something is in or out if it's close.
Mm-hmm.
And at the scale we're talking about, it would almost be just as useful to have a simple buffer distance based on stream order, maybe. Large streams get a wider distance and small streams get a narrower distance, and just say we're treating this as the floodplain. As long as we understand the assumptions behind it, then looking at where human activity may impact that zone within the distance of the stream would be just as useful, probably more useful than putting an enormous amount of effort into really trying to fine-tune that floodplain. That said, I do think having a buffer that's completely offset from the stream is a door to lots of convoluted misunderstandings. So I guess my thoughts would be get them as aligned as well as possible with the streams, but don't worry so much about pinning down the outer boundaries of the floodplains so much as doing something that we can understand the assumptions behind.
I would second that. I mean, I think that you could present the difficulties as a rationale for a more simplified buffer, but to have to have buffers that are blatantly not where the stream is doesn't seem very useful to the process.
When you say, but you mean like using the permafrost, the superficial deposit in the permafrost map? Like, is that what you mean by buffers that aren't where the stream is?
Well, like when you were matching it up with Google Earth and,
Yeah, that was
right.
So basically the line work from the superficial deposit map is just from some different source data that doesn't match well with either Landsat or Google Earth or anything we currently use. It's actually based on that old like Karlstrom 64 that's been updated since then, but obviously not fully updated. So I guess we'd have to decide whether to chuck that superficial deposit polygon altogether and just do like say we have Yukon Flats, we need a lot of buffer around that. We need to kind of create some kind of buffer area that would capture that adequately, because there's some really large floodplains that we wouldn't want to just say, oh, this order stream gets so many pixels. You'd really underestimate badly.
And maybe that tends towards the answer being some combination of techniques where you have to consider what do we really know about this stream based on other models. But
Because we did, I know Becky's using some models, and I haven't actually compared. We did that for an earlier mapping effort. We actually modeled floodplain area based on some of the similar process that Becky used, and also on the DEM, and it didn't work very well at all. It was not worth repeating the effort, but maybe for the actual stream location it would work. But
I think we could easily.
They did that for Landfire. It didn't work.
Yeah, make exceptions for certain areas where we go hand delineate, but then the general rule maybe do some three-step buffers. We'll just have to kind of maybe experiment and see what captures it best.
What's going to happen? I already kind of know what's going to happen. You're going to have like streams.
There'll be lots of
coming out of like the side of the floodplain that continue up to the headwaters. It's going to look kind of weird.
Right. Yeah. Well, yeah. These floodplains are tricky.
Yeah, this is Jim. I also had a comment that the more of a kind of a approach where you're just doing a buffer or something, the more you'll be potentially losing actual information on what the vegetation is there that So I guess I would encourage maybe the avenue you were talking about where you actually keep the original, whichever approach you use, that you kind of keep the original vegetation classification for that site. Maintain that somehow for potential future use at least.
So, like, for example, if it's spruce hardwood forest, and if it's in a floodplain, you'd rather see it classified as spruce hardwood forest and maybe without. So we haven't actually gotten rid of the underlying land cover classes. We've just kind of, you recognize that forest or spruce hardwood or within the floodplain as like the floodplain forest and shrub, but it still actually has its underlying classification. But it is attributed as a floodplain, and it might not really be where the floodplain is. So that's.
Yeah, we tried to do that for YKL, and it just didn't work to look at kind of the underlying classes. But that's because we also changed, or we fixed the floodplain. So.
But we did. We shows up vegetation classes that would be within a floodplain if their floodplain exists, and listed the buffer, and then kind of did the union between the two, and that gave us some information about riparian vegetation. Like we did that for some regions, but it wasn't.
We were hoping to pull out willow and other, specifically for
willow. That's right.
Winter forage. It wasn't very clean though.
So did you have willow within the floodplain, or it was just one big floodplain class?
Willow within the floodplain. To kind of refine where those important forage areas would be, and I didn't think it made sense. We didn't keep that. But, well, I guess we can look at a few things and see what you think makes the most sense.
Right.
Usefulness and thinking about the land use in addition to the
I know. One thing is like having those large boundaries mapped. If you're thinking about like land area inside the floodplain, keeping those larger buffers on the large rivers. Their actual map. It's actually the superficial geology, the geomorphology is mapped, not a buffer.
Right.
So you might, you probably want to keep the big river polygons like as they are, and maybe figure out a way to
Send them to include the buffer.
Or maybe we just like truncate everything that is, maybe we pick some distance, like the ones that were down to like a mile wide, they actually weren't mapped very well. Those are some of the ones I showed. They were kind of like off on their own, going up the hill or something. But the larger ones really seem to be more or less in the right place, and we could just maybe do the stream buffer at take some wider, like maybe 1.5 miles or 2 miles wide, and then anything less than that just gets buffered by some number of pixels or something in stream order.
Anybody else on the phone have
ideas on how to do floodplains better?
Or any of the other distribution models if we have approaches. Good one. Trying to think of the only other derived or other products that would use them, and I'm thinking maybe the invasive species model would use the floodplain.
Well, we haven't in the past. We've used river length and things like that, but not the floodplains themselves. But we definitely have done a lot of mapping of those, except for the North Slope. White kale on the brain.
So you probably wouldn't, for this area, necessarily use the floodplain.
We would not.
everybody on the phone. And does anybody else have any questions? Comments? Well, if you do, feel free to email Tina or myself, and we'll continue to think about these pixels. So Matt Carlson's going to talk at 2, right? 3, sorry. Yeah, at 3.
Okay, well, thanks everyone for your input, Ms. Tina. Appreciate all the thoughts on floodplains.